Today we're going to be talking about the alternate interior angles theorem and proving it. And I'm first going to start in GeoGebra by showing what they are. I'm going to move my graphics view down and start with a line. Well, we're going to have two lines that are parallel for this theorem. So I'm going to put our points down on the screen and go to this parallel line tool. Click on the point and this line. Now I have created two lines that are parallel. And now I'm going to put a point on this line, above line, and I'm going to create a line. This is my transversal. So let me write that down, type it in. And the alternate interior angles, we need one more point on here, would say that you have to remember the angle tool goes the clockwise direction, that the alternate interior angles are congruent. And in this case, they're both 45 degrees. I can move this around. It'll always be true. So there's another set of alternate interior angles, which are here, and these two are congruent to here. Okay, so let me show you how to prove this, and we're going to do it in GeoGebra. And these were just measurements, and we just measured that they're congruent, but now we're going to actually prove it. I'm going to pop out my geometry view, and I'm going to start beginning, and I'm going to move this graphics up a little bit. And let's begin. So we're going to have I'm going to get rid of these stroke lines. Well, actually, yeah, let me get rid of them. So to get rid of them, you can just to remove them, you can just click on this right here. So now I'll go to my geometry view, and we're ready to begin. So let's start labeling these. Angle 1, angle 2, and angle 3. So we are proving alternate interior angles are congruent. And we're proving angle, well, we're going to put the symbols in there. We're going to be proving angle 2 is congruent to angle 3. And we're going to do it with a 2-column proof. So I'm going to set up this right here. The left side is going to say statements. And the right side is going to say reasons. This is so much fun. And what we're first thing is what we're given. And we are given line 1 and line 2 are parallel, so we'll type it in and then I'll mark it. And this is parallel to line 2, and T is a transversal. So we'll just put a big T for transversal here. And this is going to be line 1 is parallel to line 2. And these are lines, and the parallel sign goes like this. So we are trying to prove that angle 2 is equal to angle 3. Well, we got to the first line. First, we have vertical angles. This is so much fun. So let me write down vertical angles. And where are our vertical angles that we're going to be related to this problem is 1 is equal to 2. So let me put that down. Angle 1 is congruent because it's a vertical angle to angle 2. Those are across from each other. Similarly, we have another thing that's equal to each other here. We have 1 is congruent to 3. So let's put that down. Angle 1 is congruent to angle 3. And the reason why is because these are corresponding angles. Well, if they're both equal, if 1 is equal to 2 and 1 is equal to 3, they're both equal to each other by the transitive or substitution property of equality. So we're just going to say transitive or substitution. Usually in this class they use the transitive property, but it does interchange with the substitution property. So they're equal to each other. So we can say that angle 2 is equal to angle 3. So angle 2 is congruent to angle 3. And this is what you're trying to prove in the very last line. Prove that 2 is equal to 3. The alternate interior angles are congruent. And we're going to put up our last little pound sign here to say that we are finished our proof. And that's it. I hope you enjoyed watching this video. Thank you.